So today's lesson is going to be Unit 1, Lesson 5. And again, just like our last lesson, everything that I talk about today is going to be brand new for you, unless maybe your 8th grade teacher touched on it just a little bit. We are going to discuss types of solutions that you could get when you're solving equations. So far, all of the equations that we've solved have had a single answer. And there are other kinds of equations that might have no answer at all, or even every single answer that you plug in could make it be a true solution. So let's start out by looking at the one solution. This is what we've already done this year, and this is what we're used to seeing. So one solution answers look like x equals a number when you get to the final answer. So go ahead and let's just solve this really quickly together. I'm going to move my singular x variable to the left. And then I'm left with 2 minus 1 is just 1x. Bring everything else down. Second, I need to move my constant term away from the variable term. So let's subtract 3. That will cancel, and I am now left with x equals negative 7. So that is x equals a number. X equals a number. And that is one solution satisfies that equation. Let's look at what it would look like if you had a no solution, meaning no number in the whole world would ever make this be a solvable equation, okay? So I'm going to draw my rose line. And then let's start out with our distributive property. So 2x minus 8. Let's bring down everything else from the left here. Okay, and so now I want to move my variable terms and put them on the same side. So let's subtract 2x from both sides. That cancels out, but so does this. 2x minus 2x is 0. So the only thing I'm left with after I solve this is 3 equals negative 8, which we clearly know is not true. So if you want to add here, not true, because 3 does not equal negative 8. So this is where you have two numbers set equal to one another that clearly are not equal. And so we just say that we have no solution. Another way of writing your answer no solution is just putting a 0 with a line through it. That also means no solution. All right, our last type of equation that we're going to talk about is if I have infinitely many solutions. Infinitely many, when I solve this, it will look like a number equals a number again, meaning that there's no variable terms. However, the numbers will be the same. So let's go ahead and solve this, and then we can see what we're expecting to see. So start out again with our distributive property. 2x minus 4. Bring down the plus 7. Bring down everything on the left. Now I'm going to go ahead and put my variable terms together again. So minus 2x from both sides. And again, 2x minus 2x is 0 on both sides of my equation. Bring down the 3. Bring down the negative 4 plus 7. Now, I'm not quite finished yet. I do want to put these like terms together. So let's combine. Negative 4 plus 7 gives me 3. And then bring down the other 3. This statement is a true statement. 3 does indeed equal 3. And so my answer is going to be infinite solutions. Another way to write that is using the infinity symbol. And that is our whole lesson on our first part of what we're doing today. But we're going to just do a break from listening to our video. You are going to work with a partner, and I have down below 12 different equations, and they're all jumbled up. Some are one solution, some are no solution, and some are infinite solutions. There are going to be 4 of each type. We're going to take maybe 30 minutes to work with our partner, and we're going to see if you can show all your work for every single one of these 12 problems and then categorize them based on the 3 above types of solutions. All right, so go ahead and we are going to pause the video while you do that. And I'm actually going to leave my notes up here so that you can see them. All right, so go ahead and pause your video. I want you to remember that a literal equation is just an equation, but it has multiple variables. Oftentimes, there are even formulas that we use in perhaps science class or other areas of mathematics. And we just really need to rearrange the formula to highlight a certain variable. So our job is to rearrange. All right. So in number 1, I'm going to circle the A because that's the variable that they want me to isolate. So if I look at on the left, what's next to the A, I have 3 times A times B. And so the opposite of everything being multiplied is let's divide it all. So 3B and divide the other side by 3B. On the left, the 3's and the B's will cancel, leaving me with A. And right here, I need to reduce this fraction. So let me use blue to do that. 6 divided by 3 is 2 over 1. So I'm going to bring down the 2C on top. Should be a C. C. And on the bottom, I have a 1B. If you want to bring down the 1, you can, but you don't have to. And so now that my A is isolated, I'm all finished. Let's take a look at number 2, starting out by circling the variable term that they're asking me to isolate. Now, I see a fraction in this problem, and as soon as I see a fraction, I need to find the least common multiple. Even if the least common multiple is a variable, when we're dealing with literal equations and formulas, oftentimes there is a variable in the denominator. For example, even in number 3, you can see the letter C is in the denominator. But for this one, the least common multiple is going to be a letter. All right. So my LCM for number 2 is a 2. Now let's go ahead and use our least common multiple. And what we need to do is multiply all the terms in the equation by that number. So multiply this term by 2 and this term by 2. And what's going to happen is these 2's are going to cancel out. Bring down your A plus B. Bring down your 2C. And extend your rose line back how it was. And be sure that you are still circling the B, because you want to remember to focus on the side of the equation that has the variable that you're trying to isolate. So now I have A plus B, and this is a positive A. So to move it away from the B, I need to subtract it. Now you cannot do 2C minus A, because they're not like terms. So all that you can do is write them side by side, and that is your final answer. Let's do number 3 together. In number 3, I need to solve for the letter C. My problem currently, though, is that I have a fraction, and so the least common multiple in my problem here to get rid of the fraction is the letter C. So what I need to do is multiply both sides of my equation by the letter C, eliminating the fractions is the first thing that I want to do. Now on this side, I'm only left with a B, and on this side, I'm left with a C times A. And just to help me remember what variable I'm still trying to solve for, I'm going to circle it again in green. So now I have C times A. And what is the inverse of times A? It's dividing by A. Okay, so those A's canceled. I now have B divided by A. And then I'm going to bring down my variable C, which is now by itself. All right, I would like for you to pause the video and do number 4 on your own. Give it a try. All right, I have gone ahead and shown all of my work for number 4. The first thing I did was add 2b to both sides. Remember, you cannot add 12 and 2b together. 12 is a constant term and b is a variable term. So we just place them side by side. Next, I had to divide by the 4 because that says 4 times a. So I want to divide. And in order to simplify 2b plus 12 all divided by 4, I drew an arrow up and over to the right where you see the word separate right here. I wanted to show you that to simplify these, all you need to do is separate the 2b and the 12 and keep their denominator of 4 the same. And what that allows you to do is to say, when we simplify, 2 divided by 4 is the same as 1 over 2. 12 divided by 4 is the same as 3 over 1. And so when I carried down my final answer, I didn't write the 1 in front of the B, and I didn't write the 1 underneath the 3. It is in very simplest form. Now that we've completed number 4, I'm going to scroll down, and I want you to also try number 5. I didn't realize that number 5 was also one of our reviews, and it includes a fraction, so that'll be really good practice. Pause the video while you complete number 5, and then come back and check in with me when you think that you've got it right. This is my solution for number 5. I had to find my least common multiple of my fractions because there was a fraction. It was 1/4. So I found my LCM is 4, and then I multiplied both of the terms in this literal equation by the number 4. And so I ended up with 4 times 1 is 4 divided by 4 just gave me 1. So that fraction went away. And then on the left, I have 4 times A, which is just 4A. I brought down my BC and I had my 4A. I circled the B again just to keep reminding myself of what I'm solving for. And so what I needed to do to get the B by itself was divide by that C, which made the C cancel on the right. And then that gave me my answer. B equals 4A divided by C. Great job. Now, we are going to do these last 4 problems at the bottom of our page, and these are all Math 1. What I'm going to do is I am going to draw a little tree here in the middle, and I'm going to draw arrows to this one, and this one, and this one. It's not really a tree, but a cloud. And inside of there, I need to have us add a note. I know that we learned last semester that adding and subtracting are inverses, multiplying and dividing are also inverses, but that we also learned a square and a square root are inverses. So here is a square, here is a square root, and they are inverses. Okay, now whenever we see a problem that has a square root in it, whenever we see a problem that has a square root in it, we will have to handle that square root first. Handle first. Okay? So in examples 7 and 8, the very first step of solving that is going to be to square both sides. When there is a squared, if you look in example 6, I see a c squared. Typically, we will handle the squared part, we will do the inverse of the square last. So we will handle that last. Once the c squared is completely by itself, then we will do the inverse. And so we're going to look at these together just to make sure that you understand. All right? And we're going to do 2 examples of each. 2 examples where there is a squared term in the problem and 2 examples where there is a square root in the problem. Okay, so let's do number 6. I see that I'm solving for the letter C, so I'm going to circle the letter C. And I'm going to draw my rose line. My first step is to start trying to get that C by itself, so let's divide both sides by B. Divide both sides by B because they're being multiplied. And now I have C squared equals A over B. I'm going to circle the C again. Now I have a C squared, and that's it, C squared. There's nothing else on that side with it. So the only way to get rid of the square is to take the square root of C squared and take the square root of AB. And what happens is the square and the square root will cancel each other out. And so my final answer is just C equals the square root of A divided by B. And that would extend all the way down. And that's my answer. I want us to do another one just like that. So we need to go down to number 9 on the bottom of our paper. And this is a perfect example of an EOC question. Given the formula E equals mc squared, E represents units of energy, m represents units of mass, and c squared is the speed of light squared. Which formula represents the speed of light c in terms of the energy and the mass? So this is a word problem, and sometimes students get really caught up in the extra information that they give us here. E represents units of energy. Doesn't really affect us. M represents units of mass. Also doesn't really do anything for me. And c squared is the speed of light squared. If we were using this formula to plug in numbers and to find values, we would care what these letters represented. But we need to really focus on the question. Which formula represents the speed of light c in terms of mass and energy? This part here, in terms of energy and mass, this tends to confuse a lot of students, okay? But don't let it confuse you. Very confusing, right? It's really just trying to say, solve for C. And if you're not sure that they're saying solve for C, look at all your answer choices. They all have been solved for the variable C. All right? So I am going to take this original equation right here, and I'm going to solve it. E equals mc squared. And actually, I'm not going to solve it. I want you to pause the video and see if you can solve this just like I did in our example in number 6. So go ahead and pause the video. So the first thing I did is divide by m on both sides. So E divided by m. And then in order to get rid of the square, I had to square root both sides. And that meant that the square root and the square canceled. And so I want to pick the solution that matches this right here. E divided by m under a square root, where the whole thing is under that square root. And I see answer choice B. Great job. Let's scroll back up a little bit, and we're going to go to 7 and 8. So in 7 and 8, they start me out with a square root. A square root. So let me go ahead and circle the variable I'm solving for and draw my rose line. So they gave me a square root. So the first thing that I want to do to both sides is I want to square the whole thing. Square both sides. And I always wrap it up in parentheses. Now I'm going to bring down what I have left. So here the square and the square root canceled out. A divided by B is what I have left. C squared is what I have on the other side. Now I still want to get this A by itself. So what I'm going to do is multiply, because this says A divided by B. The opposite of dividing by B is multiplying by B. So I'm going to multiply by b on both sides. And now I have a equals c squared times b. Or you could even write b times c squared. Okay, either way, it still represents the same correct answer. Let's try 8 together as well. I want to do 8 with you. If you look at 7 and 8, the initial problem, the square root of a over b equals c, is exactly the same. The part that's different is what I'm asking you to solve for. It's important to know how to solve for what might be on the top of the fraction, but also for what's on the bottom of the fraction. So I'm going to circle the b this time. My first step will be the same. Square both sides. Okay, square root's gone and the square is gone. So I just have a over b equals c squared. Now I am solving for the b. But again, because that b is in the denominator, I need to multiply both sides by b. Again, that's how I get rid of my fractions. So multiply both sides by b, and now I have a equals c squared b. B is still what I'm trying to solve for. So c squared times b, how would I get the b by itself? And I will need to divide by the c squared. So I'm going to write my answer over here. I now have b equals a divided by c squared. And let me circle my answer over here as well. So that is literal equations, but on the Math 1 level. It involves using squares and square roots within the literal equations. For homework tonight, there is a Quiz-Is posted onto Google Classroom. I do want you to take your time. Remember to use all 5 of your tries to get the best score possible.